Welcome back, Geometry Scholars. Today's lesson is on angle, angle side, AAS Triangle Congruence, and hypotenuse leg, HL Triangle Congruence. Today's essential question continues to be, how does algebraic knowledge of lines help to solve problems about geometric concepts? And you're going to see those lines come into play again today. And the the lesson objective for today is that you will be able to determine if two triangles are congruent, and if so, explain why. On the left-hand side of your notes, please make sure you're writing any questions you may have. First up, the angle side congruence theorem states that if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. Notice here, angle A congruent to angle D, angle C congruent to angle F. They're already marked for you. There also is a congruent side. BC is congruent to EF, but notice it's not that included side, okay? It's a corresponding side, but it's not the side that's between the two congruent angles. As long as we have two angles and another side, we can prove triangles congruent. And once we know that triangles are congruent as wholes, then we know the individual pieces are congruent as well, because corresponding parts of congruent triangles are congruent. And we learned that back in lesson probably 3.3, but it was a few lessons back. So keeping that in mind, once we prove the whole triangle is congruent, we know that the individual pieces are congruent as well. The hypotenuse leg theorem, or HL theorem, states that if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second right triangle, let's just say, you want to write under there right triangle, then the two triangles are congruent. Keeping in mind, these must be right triangles. I don't care if they look like right triangles. If they're not marked right triangles, you cannot assume they're right triangles. It has to show perpendicular lines which create those right triangles, but otherwise do not just assume that if you see something that looks like a right triangle that it is. It must be marked that it's a right triangle, or be able to be proved that it's a right triangle. So here I very clearly have right triangles. They have a hypotenuse of one that's congruent to the hypotenuse of another, and they have a leg of one that's congruent to the leg of the other. Okay, so as long as it has a congruent hypotenuse and a congruent leg, we are good to go. They are also congruent. We're going to do some practice here. We're going to decide whether we have enough information to prove that the triangles are congruent. If yes, we'll state how. I'm going to do A and D with you, and then I want you to do B, C, and E on your own and check them. So looking at A, can we prove these congruent? Okay, what do they already have? I see that it already has an angle and another angle. What else do we know? Well, they share a side. So the reflexive property, they have that congruent side as well. So that's a side. Is the side the included side? Is it between the two angles? No, it's not. So these are congruent, but they're congruent using the angle side theorem. So angle, or angle, and then the side is the non-included side. Okay, looking at letter D. Now letter D is a little tricky. Some of you today, when we reviewed proofs, you had one similar, it had a shape similar to D where you dealt with parallel lines. Now I know that these are parallel lines because they have these arrow marks on the line. So whenever you see arrow marks on lines, that means we're dealing with parallel lines, and you should already know that. We've talked about that before when we first started talking about parallel lines. So looking at these lines and looking at these shapes, what do we already know? Well, they clearly give us a side. Okay, they've marked a side for us. We're good to go there. We also know that vertical angles are congruent. So we are either going in the direction of side, side, or angle, side, angle. I don't know yet. So, but we have a side, we have an angle. So, can we prove another side? We cannot. With the information they've given us, we cannot prove another side. Can we prove another angle? And yes, we can, because we know two of the lines are parallel to each other. So what I'm going to do is I'm going to extend the lines so you can better see this. I'm going to extend to this line, and I'm extending, I'm sorry, I'm trying to be as straight as I can, that line, okay? And then I'm going to, with this blue marker, I'm going to extend the transversal. So here are my parallel lines in red, and I've drawn the transversal in blue, okay? When I intersect parallel lines with my transversal, I create all of these angle pairs. And I am looking right here, and by creating my angle pairs, right here and right here, I have formed alternate interior angles. Alternate interior angles. I also have right here and right here, but they're not on the inside of my triangle, so I don't care about those. I'm going to erase those. But just so you know, we formed two pairs, but I don't need those because those are on the outside of the triangle. But here and here, okay? So now I have another angle. I've just proven another angle. And SAA isn't a thing, so I have to think about, am I going to use AAS, or am I using ASA? Let's look at my angles. I had originally marked these vertical angles, and I have a side, and now I have another angle. So it really comes down to the side. Is the side in the middle of the two angles? In this case, it's not. We have two angles, and the included side would be this one right here. But we're not using that side. We're using a different side. So for this answer, it would be yes, AAS. Okay? Yes, angle, side, angle. Lucky for you, and maybe some of you already thought this as we were doing it, this actually can be proved another way. So I'm going to show you another way. I don't mean to confuse you, but I need to make sure you fully understand. So here are my parallel lines. They're coming down, and this time I'm going to use the other transversal. Okay. Again, I already know I had a side and an angle because I have the marks shown, and then I have the congruent sides. Okay. I'm looking to see I can make, again, alternate interior angles. So this angle is congruent. Oh, I should have actually marked that twice. Sorry. That angle is congruent to that angle, alternate interior angles. So now I have my other angle. Looking this time, is my side included? Well, yes, my side is included this time. It's between the two angles. So here you could say it's congruent by the angle side theorem or the angle side angle theorem. Because we have parallel lines, we have more options. I don't expect you to know this right now. We're going to get there, but I need to expose you to it. Okay? As long as you're trying, that's all I can ask, but I need you to put forth the effort. Go ahead and pause the video and please finish B, C, and E, and then check the video with your work. Letter B was yes, because of the hypotenuse leg theorem. I can tell that it's a right triangle. It's marked. They have a leg in common already, and then they share the hypotenuse. They have the same hypotenuse, so reflexive property is congruent. So yes, the hypotenuse and the leg are congruent to each other. Letter C is no. Although they do share a common side, I cannot prove that their hypotenuses are congruent. So that would be a no. And then yes, they already show us that the hypotenuses are congruent. Remember, the hypotenuse is the side across from the right angle. And then they share a leg. So these can, yes, be proved that they are congruent using the hypotenuse leg theorem. So B was yes, HL, C was no, and E was yes, HL. Going on to example 2, this is a practice of what we did today in class. State the additional information that is required in order to prove that the triangles are congruent by the given theorem. So, they want us to prove it by AAS. What do we already know? We have an angle congruent to an angle, and we have an angle congruent to an angle. And both of these angles, actually, B and C are both congruent to E and F. So whatever the measurements of B and C are, they're the exact same for E and F. So if this was ASA, we would say, oh, we need BC congruent to EF. but this isn't ASA, this is AAS. So we need a non-included side. And you actually have two options. You can go with option 1 or you can go with option 2. Doesn't matter. If you go with option 1, you could say that AB is congruent then to DE. So I either need that AB is congruent to DE, or I need, I'll make it that big or, okay, or I need that AC is congruent to DF. I need either of these pieces. On the quiz, or if I were to ask you to give me something that would prove them congruent, I only need one of those pieces, but I wanted to show you that you could provide either one, and either one would be correct, because either one is a non-included side. Okay, let's look down at letter B. They want us to prove this by the hypotenuse leg theorem. We already know that it's a right triangle, so we're allowed to explore the hypotenuse leg theorem. Although it's not marked, we know they have a leg congruent because BC is congruent to BC. So that's a leg, so what do we still need? We need the hypotenuse. So we need that AB is congruent to DB. That's the, oops, sorry, DB. Said it, but didn't write it. DB. Once we have that information, then we would be able to say that they are congruent to each other. So that's what we're missing. We're missing the hypotenuse to be able to solve it by the hypotenuse leg theorem. Last thing for today is we're going to fill out this proof together. So first of all, the statements are what we're proclaiming to be true. The reasons are why they're true. The first couple of statements are always going to be the given. Okay? So they gave us that angle J and angle L are, oh, I spelled R wrong. Are right angles. And if you want to abbreviate, that's fine. I have the angle mark, and then I say R. RT is for right, and then the angle mark, S for plural, are right angles. How do I know that? I don't even have to guess. It's the given. Okay? And it's already marked for us. So I know these are right angles. Okay? They also tell us that K is the midpoint. I'm going to write MP, midpoint, of JL and MN. Okay, K is the midpoint of both. And again, this is the given because they gave it to us. Now, if something is the midpoint, it's cutting it in half. And it's only we can only say it's cutting that in half. Since K is cutting two things in half, that actually helps us more. K is cutting JL in half, so that means JK is congruent to LK. And like one class said today, if they give us the midpoint, does that mean we're doing something with it? Yes. If they're giving you something, assume that you need it. So, since they gave us the midpoint, we probably need to know something about these lines. So, JK is congruent to LK. But we also know that K is the midpoint of MN, which means that NK is also congruent to MN. Okay, so K is cutting MN in half as well. So we'd also say NK is congruent to MK. And I realize I'm getting in the way of the next line. So NK is congruent to MK. And we know this to be true. If you did the proof this morning or during class, we know this to be true because of the definition. So definition of MP midpoint. If you want to write it out so you don't forget what MP stands for, write it out. Okay? If you're comfortable, you can call it MP. If you don't know, write it out. So now can I prove these triangles are congruent? Do I have enough? Well, they're right angles. I have congruent hypotenuses, and I have a congruent leg. Is that enough? Yes, it is. So you would just say triangle JKN is congruent to triangle LKM. And this is true because of the HL theorem, or HL congruence theorem, however long you want to get. As long as I saw that you knew HL, I would even be satisfied with that. Okay, so our last statement is always what we're trying to prove. Okay, so again, angle J and angle L are right angles. That was our first given. Number 2, that was K is the midpoint, MP, of JL and MN. That was our next given. Number 3 said that JK is congruent to LK and NK is congruent to MK. And then we proved that triangle JKN was congruent to triangle LKM due to the hypotenuse leg theorem. We will continue practicing proofs. Now, proofs are an ongoing thing that you will be learning. However, you need to be memorizing the things that we use as reasons. What does midpoint mean? What do these theorems mean? What does reflexive property mean? If you don't know what those things mean, you will have no idea how to write a proof. But the more you understand about geometry, the easier you'll say, oh, okay, I get it. I'm proving something. Here's why this is correct. Here's why I can say JKN is equal to LKM, because they have this in common or they have that in common. Lastly, please write your summary, at least one sentence about what you learned, or if you have any questions, you can write them here as well. Have a great day, guys, and I'll see you next class.